Lesson 5.7 is graphing linear inequalities in two variables. So basically we're going to graph lines, but instead of having it just equal the line, now the solution set is going to be ordered pairs instead of just a point on the line. So they're going to be different ordered pairs. So it's basically just taking a line and substituting, instead of an equal sign, you're going to put in an inequality sign. And again, the ordered pairs are what's going to end up satisfying the solution. Now, you will find some problems in your assignment where they ask you, is this ordered pair a solution of this inequality? I believe that you can do that without actually having an example, because we've done these many times before, where you substitute in the x, you substitute in the y, you do the arithmetic, and you see if it's a true statement or a false statement. So I'm not going to take the time out to do that here. When you graph an inequality, the graph of the inequality in two variables is the set of points that represent all solutions of the inequality. Again, you're going to have more than one right answer, and you'll see how we represent that. What we're going to do is we're going to graph a boundary line, and the boundary line divides the coordinate plane into two half planes. Sometimes that's hard to wrap your mind around, because when I think half, I think directly in the middle, which it is, but when you are given a finite space to graph in, it's hard to see that the line actually cuts it in half, because even though you're given the finite space to graph in, theoretically it goes on forever. And only one of the half planes contains the points that represents the solution. So these are the steps that you're going to follow. So first you're going to graph the boundary line, and this is important. You're going to use a dashed line if it's less than or greater than, and a solid line for less than or equal to, or greater than or equal to. The reason you do that, if it's a dashed line, it's showing that the points on the line are not part of the solution set. And if it's a solid line, the points on the line are part of the solution set. Next, we're going to test a point that's not on the boundary line by checking to see if it's a solution of the inequality. And then lastly, you're going to shade the half plane that contains the point if that ordered pair is a solution. If it's not a solution, then you shade the other half plane. So here we go. First we have 4y is less than 6x minus 2. First thing I'm going to do is divide everything by 4, because you still need to get it in slope-intercept form. So when I have 6 divided by 4, that's technically, if I simplify it, 3/2 x minus a half. So now I will go ahead and plot my point out, or my y-intercept is -1/2. My slope is 3/2, so up 1, 2, 3, and over 2. It is less than, so it's going to be a dashed line. So there's my dashed line. So there's step 1. Step 2, I have to decide what part of the half plane I shade. I like to test 0, 0, because it's the easiest point, I think, to test. Now I can only test 0, 0 if it's not on the boundary line, and in this case it's not on the boundary line. So when I go to test 0, 0, I put in 0 for the x and 0 for the y. I like to do it in the original. Well, sometimes I do it in the manipulated one, but here I'm going to do it in the original. So if I go 4 times 0, that gives me a 0, is less than 6 times 0 is 0, minus 2 is -2. So this is actually false. 0 is not less than -2. So that means if I look right here, here's the 0, 0. You don't really need to, well, don't put a point there, but I'm just doing it for demonstration. So I want to shade the half plane that does not contain 0, 0. So I'm going to shade this portion right here and give it a good old shade. So what this means is any ordered pair within this half plane, so again, theoretically I can go on forever and ever and ever in this direction, and the line will keep extending. Any of these are solution points for this inequality. Let's try another one. So here we have 5y is less than or equal to 10x plus 15. So I'll divide everything by y, or by 5. Y is less than or equal to 2x plus 3. So here's the 3. My slope is 2. And this time I have a solid line because it's less than or equal to. So solid. And again, I look to see, and 0, 0 is not part of my solution set. So I'm going to choose 0, 0 to test. If I do that, I end up with 0 is less than or equal to 15. And that is true. So I will shade the half plane that contains, oops, not erase. I will shade the half plane that contains the 0, 0 point. So again, any point in this half plane or on this boundary line is a solution for that inequality. Let's try this one. I will add the 3x, so 2y is greater than 3x minus 8, divide by 2. So y is greater than 3/2 x minus 4. So I'll put it on negative 4, 1, 2, 3 over 2. And again, I have a dashed line here because it's just greater than. And just to be different this time, to show you that you don't always have to do 0, 0, I'm going to pick the point 1, 1 because that's an easy point to check also. So if I do 1, 1, that gives me 2 times 1 is 2, minus 3 times 1 is 3. Is that greater than negative 8? Well, 2 minus 3 is negative 1, which is greater than negative 8. So that's true. So 1, 1 is here, so I will shade this portion of the half plane. Okay, next. In some cases, you will experience vertical and horizontal lines. Remember, when it's just a y with no x's, it is going to be horizontal. So I come up here to 7. It's just greater than, so it's going to be dashed. And again, I test a point. If I pick the point, let's say 2, 2. This is right here because that's not on my boundary line. Really, I'm only substituting in the y because the x is non-existent here. So is 2 greater than 7? No, it's not. So I shade the half plane that does not contain that point. And you do the same thing with the vertical line. Here I have x is less than or equal to negative 5. So that's this right here. And it is solid. Scooch it over just a little bit. And I can test any point here as long as it's not on the boundary line. So let's just randomly test this point, negative 2, positive 2. And I'm just substituting in the x because, again, the y is non-existent here. Or I should say the y is always negative 5. So I will go negative 2 is less than or equal to negative 5. Well, that is false. So I have to shade this portion of the half plane that does not contain, oh, need to select the right tool here. So I shade this portion of the half plane. Okay, in some instances they're going to ask you, they're going to give you a graph to look at, and they're going to ask you to come up with the inequality for this. So the first thing I need to do to come up with the equation of any line is pick 2 points. So I will pick this point here and I will pick this point here. And since I have a picture to look at, I'm just going to do the rise over the run. I'm rising 2 right here and I'm running 1. So my slope is 2. And on this one it's nice. The y-intercept is given to me. It's negative 5. So I know that I have y and I have 2x minus 5. I have to decide, is this greater than, less than, greater than or equal to, or less than or equal to? I do know that it does not include equality because it's a dashed line. And I know that 0, 0 is in the shaded region. So I have to see what happens with my 0, 0. So if I plug in 0, 0 for my x and my y, then I end up with 0 and negative 5. Again, I don't have a sign here. I have to decide. Well, 0, 0 is in the shaded region, so is 0 greater than negative 5 or less than negative 5? It is greater than. So my inequality sign is greater than. Okay, here's an application problem for you. You're going clothes shopping and can spend at most $130 on clothes. It costs $30 for a pair of pants, $22 for a shirt. We're letting X be the number of pants and Y is the number of shirts. So first they want us to write an inequality for this. So it's $30 for a pair of pants plus $22 for a shirt. I have at most $130, so I can't go over it. So it's less than or equal to $130. Now I'm going to graph this. When I graph this, I'm going to go ahead and figure out the x and y intercepts. A lot of times on application problems, I think that works best. It's just quicker. So we're going to find the actual x-intercept. So 30x, instead of going less than or equal to 130, I'm going to go equals 130. And when I take 130 and I divide it by the 30, I get 4 1/3. So x is 4 1/3. So I will go ahead and plot that point right there. And the y-intercept, 22y equals 130. So 130 divided by 22 is about 5.9. If we put it as a fraction, it would be 5 10/11. So almost 6, so right here. This is a solid line, but actually it's a line segment because I'm only given so much money. Let's change this to, oh, it is on solid. All right. And it's less than or equal to. Hopefully it makes sense to you that if it is less than or equal to, you're going to shade below it. But let's go ahead and test. Again, I like the good old standby 0, 0. So if I test 0, 0, I end up with 0 is less than or equal to 130, which is true. So I'm going to shade this portion right here. I'm not going to go beyond this, again, because I only have $130 and you can't buy negative pairs of pants and shirts. So here's part A. Part B, give 3 possible combinations. So any 3 combinations of whole pairs of shirts and pants. So I can buy 1 of each. I can buy 2 pants and 1 shirt. I could buy 3 pair of pants and a shirt. I could buy 1 pair of pants and 3 shirts. I could buy 0 pants and 4 shirts. Anything in here or on the line. I could buy 2 pair of pants and 3 shirts. So I'll just put here answers may vary. You don't put that though. You put some actual combinations from up here. All right, here is your assignment. We're actually going to do this in a couple different parts, but I wanted to give you all the notes so then when you come to class on the next day or over the weekend, you are actually prepared for it. So this is part 1 of 5-7, page 351 to 352, problems 1 and 2, 8 to 14 even, 15, 16 to 36 even, 37, and 38.